Alright, so I just wanted to try to solve problem 4. So first I'm going to choose a system, something like that, right? And I got weight down, and there's one of the tensions, one of the ropes, and then the other rope is like in that direction, right? And I don't really know how long the weight is. It could be shorter than that, but I don't know. Maybe about like that, let's say. Again, I don't know what the length of the weight is. So there's my weight. I'll call this one T1. Actually, they're going to be the same magnitude. T1 and T2 are going to be the same just by symmetry. There's T2. Okay. And if I draw a reference line going across, I'll find that this is 30 degrees and this is 30 degrees, right? And these vectors, since there's no acceleration, that is, the velocity of this object isn't changing, that means the forces need to add to 0 as vectors, right? This is N1. So I'll go ahead and do that. I got T2 in this direction. Okay. I got T1 like in this direction. I'm just trying to show the forces adding to 0, right? So this is my T2. This is my T1. And so my weight has to go straight down. There we go. And the object is hung from a cable. The object hung from the cable has a weight of 25 newtons. Okay, so we know this. Well, why don't I just figure out some angles first? That'll make it easier. So if I draw this, right? And then I make horizontal. Oh, that's one way of doing it. There's a couple ways of doing this. I'm going to make another argument. I like this way. This argument's way simpler. Okay. If I connect this down here on my force diagram, I can easily see that this is 30 degrees, right? And so this whole thing has got to be 60 degrees. And that means this side's 60. That means this side here, so if I can prove that part, if I come down this way, like this, yep, there we go. If I connect this one down here, I'll see that this is 30, which means, this is super cool. I'm thinking that the weight in T1, I'm thinking that if I draw this one up, there's a reference line there. Okay. I'm just trying to find the simplest way. I'm pretty sure this is a 60, 60, 60 triangle, right? Maybe I can prove it this way. That would cut the 60 into 30. This is a 90, so that makes this 60 and this 60. So it is a 60. This 60 degrees goes all the way down. Okay? So 60 degrees is this angle there. So I'm just trying to prove that it's a 60, 60, 60 equilateral triangle. And what that means is the weight has to equal T1, which has to equal T2. And in this case, we're told that the weight is 25 newtons. So I just think that problem is interesting. I like it. It's beautiful when it's so simple. Anyway, hope you enjoyed it too. And have a good day. Bye-bye.